So Pythagorean theorem says x squared plus, I want to say my coffee is kicked in. 5 times 5 is 25. My coffee is kicked in. 7 times 7 is 49. Okay. Thank you. Wait, careful, huh? We got to get x by itself. Let's subtract 25 from both sides to get x alone. I'll bring it down here since I have some room here. I end up having x squared equaling 24. Reyes, what do I do at that point? Hold up. Give me a second. Reyes, hit it. Square root. Watch this now. Okay? That gets rid of the second power, so x is equal to the square root of 24. I don't want approximations right now. I want exact simplified, which we practiced last week. I have my list of perfect square factors on the board still from last week. Let's break down rad 24. Which number from this list fits into 24? Thank you. Look at 4 fits in there. Remember, as long as you have one factor that comes from the list, you're rocking and rolling. Look, there it is. So 4 and 6. 4 comes from the list, 6 doesn't, but it's okay as long as one of them comes from the list. We practiced this last week. Thank you. So look at the exact, this leg here, this leg is exactly 2 times rad 6. Look at it. That's what x is. X is 2 rad 6. Not approximately, exactly. So far, so good. Now we can find the sine, cosine, tangent, cosecant, secant, and cotangent of theta, because we know all 3 sides. Let's do it. Sine theta, cosine theta, tangent theta. Let's do the first 3 first, the classic ones, the ones we're familiar with, and then we'll do the last 3 after. I agree. Let's see, sine of theta. One more time? Thank you. I got SOHCAHTOA up here for those of you who still refuse to memorize this word. Shame on you if you don't know this word by now. Sine is opposite of hypotenuse. Sine of theta. Opposite is 5, hypotenuse is 7, so it's 5 over 7. Nice. Cosine. Adjacent over hypotenuse. 2 rad 6 is adjacent to theta. So that's 2 rad 6, numerator, hypotenuse 7. Nice. By the way, if we're able to simplify 2 and 7, in other words, if we can simplify that fraction with a common factor, let's do it. But right now, 2 and 7 can't be simplified, so we're cool there. How about tangent time?
Over 2 rad 6.
Gracias. Opposite over adjacent. TOA, SOHCAHTOA, the TOA part of SOHCAHTOA. Opposite over adjacent is 5 over 2 rad 6. Nice. Now, before we move on to the last 3, the cosecant, secant, and cotangent, there's something I got to say here about this tangent. Now, in normal human interaction, there's what we call good manners and bad manners. Like right now I'm talking and some people have bad manners, they have their phone out. That's bad manners. Let's say you're at a party and you walk into a room and there's people you don't know. If I go up to another guy and shake hands with him with my left hand, that's actually inappropriate. You should shake hands with your right. A lot of people don't know that, but that's actually an old tradition. You always shake hands with your right because your right hand is your good hand, your hand of strength. And so you're giving your hand of strength as a communication of friendship. See, so Flotus just offended Hall right there by giving his left hand out. That's sad. Here's other bad manners. If you're at a dinner party, let's say, chewing with your mouth open, bad manners. Putting your elbows on the table while you're eating, bad manners. Farting at the table or burping, bad manners. Okay, so there's bad manners in human interaction. Now, why am I bringing that up? There's kind of bad manners in mathematics too. This fraction right here that has an irrational number on the denominator, that's bad manners mathematically. Even though the answer is correct, technically it's correct, it's just bad manners to leave it with the denominator having an irrational number, namely rad 6. That's irrational. It's okay for a numerator to have an irrational number. That's okay, but for a denominator to have an irrational number, bad manners mathematically. It's like chewing your mouth open. Let's not do that. So here's what we're going to do. Okay? Go to right. Rationalize a denominator. We're going to make it rational. Right now, the denominator has an irrational number. We're going to rationalize it and make it rational. So go to right. Rationalize denominator. Minator. Write that, please, on your notes. Rationalize the denominator. Never leave it with an irrational number. Bad manners. Even though technically it's right.
So we do that on the quiz.
So is that we're good? Wrote that down? Nice. Go ahead.
So if we do that in the quiz, are we still going to get credit or not?
The question always comes up. Because we'll do the bare minimum. If you're a teacher and you taught your students to rationalize it and they don't on the quiz, what would you do?
So yes or no?
He's going to be a good teacher one day. You're going construction now. I'll cross that bridge when we get to it, but here we go. Let's rationalize the denominator. Here we go. Here's how you do it. Here's how we do it. 5 over 2 rad, let me write it again. 5 over 2 rad 6. Here's what I'm going to do. I'm going to multiply 5 over 2 rad 6 by a number, namely the number 1, to get an equivalent fraction without the irrational number, though. In other words, if you multiply any fraction by the number 1, you'll have the same fraction just in a different form. And the number 1 can be written in an infinite amount of ways. What do I mean by that? Watch. Don't write this down yet. Isn't 5 over 5 the number 1? Yeah. How about 7 over 7? Isn't that the number 1? Yeah. I can write the number 1 in an infinite amount of ways. I can be here till the cows come home, writing the number 1 in different ways. As long as the numerator and denominator are the same number, it's the number 1. So here's the mission. What form of the number 1 do I multiply 5 over 2 rad 6 by to get rid of the radical 6 on the denominator? That's the mission. Let me try 7 over 7. Let's see if it works. Watch. Don't write this down right now. 5 over 2 rad 6 times 1 in the form of 7 over 7 will give me what? Let's see. Numerator times numerator, that's going to be 35. Denominator times denominator, let's see. 2 times 7 is, I got 14 rad 6. Look at this fraction is the same as that fraction, just in a different form. But I didn't get rid of the irrational number on the denominator, so that didn't really help. The point I'm trying to communicate, though, is that if I multiply any fraction by the number 1, I still get the same fraction in a different form. This is still equivalent to that. It's a different form. Because I multiplied only by the number 1. Because anything times 1 is itself. Think logically. Anything times 1 is itself. A fraction times 1 is still itself, but just in a different form. The question, though, is, what form of the number 1 do I use to get rid of that radical 6? It's like a game. 3 over what? Let's try 3 over 3. If Nava gets it, you get 2 extra stamps. I'll write it down. Let me test Nava's theory out. He says 3 over 3. You're ready, Nava. 2 steps. Numerator times numerator, I got 15. 2 rad 6 times 3. The normal number times normal, that's going to be 6 rad 6. Good try. Irrational number still in the denominator. Anybody else? What form of the number 1 will I use to multiply this to get rid of that irrational number?
3.
Over what? 6? Let's see if Lotus gets it. 5 times 6, numerator times numerator, 30. 2 rad 6 times 6, that's going to be 12 rad 6. Good try, Lotus. That's still the irrational number on the denominator.
It's going to be the same thing in different form.
So Nava's saying now it's impossible. So I'm wasting my time in saying rationalize the denominator. Okay? Anybody else? Free assignment pass. You heard me. What form of the number 1 do I use to get rid of that irrational rat 6? I'll give you a free assignment pass. Hit it. One more time. Try it. You get the free assignment pass if it works. Let's see. That's 1 for sure. So 5. 5 times 8, 40. 2 rad 6 times 8, let's see, 2 times 8, that's going to be 16 rad 6. Good try, though. Anybody else? Free assignment pass, ladies and gents. What form of the number 1 will eliminate that rad 6? That's the mission here.
0.
0 is not 1, that's 0. But I like how you're thinking, though. You're trying to think outside the box. Good try, that's not going to work. Free assignment pass. Going once, Hall. Florida, tell me. One minute. I'm gonna pour 1 cup of coffee and I'm gonna come back. If no one gets it, I'll just do it. I'll get the free assignment pass. I'll get the free assignment pass. Coffee's good, by the way.
Yeah.
Anybody, hit it. Oh, shoot. Can I do this real quick? Thanks. Anybody? Free assignment pass.
Why don't you just multiply by the problem itself?
But, you mean by this fraction?
Yeah.
That would be a good idea, but this fraction doesn't equal to 1. Remember, it's got to be a form of 1. Where the numerator and denominator are the exact same. That's the number 1, huh? This is actually not 1. I like how you're thinking, though. Hit it, yes. 3 over... We already tried that one. I think someone said that already. It didn't come up. Anybody else? Uh-oh. Uh-oh. 5 times 9, 45. 2 times 9 is 18, so 18 rad 6. Good try, though. Well, that's the free assignment, guys. I want you to think about it.
Is it gonna be gonna be 2 rad something, or?
If I tell you, then you'll get the free assignment pass, and I don't want to give you the assignment pass. Let's see. 30 seconds, and I'll get the free assignment pass. Nah. Last period,
16.
Dominic Viela got it last period. If you know Viela, you can text him real quick. You got 10 seconds.
You already tried 3 times 3. 3 over 2. 4 over 4.
That won't work. Try that one. All right, I'm gonna give it to you. Here we go. So go ahead and write this with me now. Here we go. Write this with me. Look at the form of 1 I'm going to use, Samudio. Watch this. Radical 6 over radical 6. Oh, wow. Right. Isn't that 1? That's 1. And watch what happens. Watch what happens. Numerator times numerator. 5 times rad 6 is 5 rad 6. It's okay to have an irrational number on the numerator. Watch what happens now, though. 2 rad 6 times rad 6. The radical times radical, I can go ahead and multiply. Radical 6 times radical 6 becomes radical 36. Look at it. And I got the 2 out there. Well, what is radical 36? 6. So the irrational number's gone. Watch what happens. This becomes now 5 rad 6 on the numerator over 2 times 6, which becomes 5 rad 6 over 12. This is the good matters right there. So this fraction is equivalent to that fraction, but it's good matters because the denominator is rational, not irrational. We just rationalized it. No, it's like 2 times 6. Because remember, look at it. This means 2 times square root of 36, but the square root of 36 becomes 6. Okay, this means 2 times whatever this is, so it's 2 times 6. Okay? 2 times 6 is 12. Done. This is the rational, good matters version of the tangent. So we found our tangent. So far, so good. Where are we at? Let's regroup. We found the sine, we found the cosine, we found the tangent. The tangent had to be expressed as a rational denominator. We rationalized the denominator. Now we're ready to find our cosecant, secant, and cotangent. Here we go. Cosecant, CSC theta, secant theta. You're not taking notes. You're looking at STEM. Trust me. Cotangent theta. Nice. This reciprocates what, Ariaga? The sine. So sine was 5 over 7, so the cosecant 7 over 5. That was easy. Nice. Secant reciprocates the cosine. Cosine was 2 rad 6 over 7, so this is going to be 7 over 2 rad 6. Uh-oh. Look at the denominator. It's irrational. I got to rationalize that puppy. Sorry. What are you mumbling, man? Watch this. Here we go. What form of 1 will I use, ladies and gents, to rationalize that puppy? We got to rationalize it. Go ahead. Over rad 6. There it is. Look at it. Do that with me. Rad 6 over rad 6. Again, this is technically correct, but it's bad manners. I got to rationalize the denominator. Here we go. 7 times rad 6 is 7 rad 6. There's my numerator. 2 times rad 6 becomes 2 times rad 36, which becomes 7 rad 6 over 2 times 6, which becomes 7 rad 6 over 12. Here's our secant. There's our secant. Again, the rad 36 becomes 6, so 2 times 6 is 12. Right, Uriaga? It became 12?
Yeah.
I am.
Are you not going to
We're on YouTube right now.
Oh.
Come back in about 5.
On YouTube.
Cotangent. Question so far. Last one now. Let's reciprocate the tangent. The tangent was 5 rad 6 over 12. If I look at this. If I reciprocate the 5 rad 6 over 12, I'll end up having an irrational rad 6 at the denominator. So I'm not going to reciprocate the good manners one. I'm going to reciprocate the bad manners answer. Look at the bad manners answer. That one. I'm going to reciprocate that one. This way it saves work. I'll put the 2 rad 6 on top and the 5 at the bottom, we're done. So I'm looking at the bad manners answer for tangent to reciprocate. It saves time and money and work and energy. So this is the one I'm going to reciprocate for the cotangent. I'm going to have 2 rad 6 over 5. Look at that. Done. I didn't reciprocate the good manners one because then I'd create more work. I reciprocated the bad manners one. When you guys saw that strategy. I don't want to reciprocate that one because then I have to have more rationalizing to do. I trust that made sense. Raise your hand if that didn't make sense.
Oh, damn it.